Perhaps it's interesting to show how you can connect these very well-known units to measure voltage and current in case of a power supply, etc. This is the power supply at the moment, shortcut protected. I did not do many adaptations. So anyway, I switch it off because the ventilator gives too much noise. So here is that unit from Ali, well known. It tells volt and ampere. This is how the backside looks. There is a chip, of course, inside. Everything beautifully made and very cheap. And they are from China with two plugs with wires. Together we have 5 wires, and I will tell how I connected them. I have to put down the camera because I want to switch in these wires first. You can click them in, very easy. Very easy. I say very easy, but anyway. So this one is clicked in, and this 1, 2. I think, of course, it must be clicked in the right way. So now these wires are connected. You find here all these wires. Well, anyway, I give an example that only regards the situation where you have to measure voltages and currents that go higher than the unit itself can handle. The unit itself can handle 30 volts maximum, but in my case I'm working with 49 volts. So in that case you must supply the unit here via a separate voltage source. And all the indications here are now in Dutch, in the Dutch language. Here is the translation. But I also colored the schematic so that you cannot make serious shortcuts or so. In that case that I mentioned, where we have to measure voltages up to say 100 volts or so, there must be a separate power supply, and that separate power supply is connected here via the thin red wire. And when you look closely here, you can see 3 resistors, all are 0.5 watt. And this also, I've done that by purpose, so that you can use cheap resistors, not specific high power resistors. What we can see here is that we have 49 volts. It goes to the zener. The zener stabilizes it on 12 volts, and when you read the data sheet it can also be, for instance, 20 volts. In that case, of course, you have to search out other resistors. Anyway, this works. Small capacitor here, 47 microfarad, thin wire, and that is this thin wire here. Then we have the fat black wire. It has to be connected to the minus of your circuit. Here, this is the minus wire. Here you can see it goes to the minus. The thin black wire also goes to the minus here. And then we are with that yellow wire. That yellow wire picks up the voltage to be measured. It's connected here at the end of the unit. This is now the voltage regulator, but it can be any circuit. That's important to tell. And here is the red wire, and there is something peculiar with that red wire. Normally we know that red means positive, But when you study the schematics on the Ali website, you see that that red wire has to be connected to, say, the underside of the load, in this case the minus. And the reason is that there is here inside a shunt resistor, and as far as I could see it is R018 here, this one, and that shunt resistor, over the shunt resistor the current is measured, and that is in a certain way a kind of problem, because I want to make this power supply that we have a complete real earth without any, say, resistance in the earth wire. But now when you want to use this unit as an amperemeter, there is that shunt wire. So here we have that minus wire. There is somewhere here inside the shunt wire, the shunt resistor, I mean shunt resistor. Also here I'm talking about the shunt resistor. So that means that there is a tiny resistance in the earth wire. I do not want that, I did not want that, but it does not have to be a problem. That's important, and that's the reason why I have made this connection, this switch here, this switch, this one, and it realizes that we can use this power supply without the shunt resistor in the measuring unit. Of course, in that case, the measuring unit for amperes does not work any longer. That's logical. When you shunt out here a very important component, say the resistor parallel to which the current is measured, this doesn't work any longer as an amperemeter, only as a voltmeter. I can demonstrate that. But anyway, I want to use this for audio amplifiers, and in that case I want to have the possibility to switch in a pure AC line without a shunt resistor in that, I say AC line, pure earth line, earth wire, without a shunt resistor in that earth wire. So I made that switch, I shortcut the shunt here, and then I have a good voltage indication, but the amperes indication is disabled. Hope it was a little bit clear. Want to demonstrate it. Let me pan over first somewhat. I think it's a very good, usable unit, and again, like I say, you don't have to use this setup, and I mean don't have to use this setup in combination with a power supply, though that's logical, of course, but anyway. So you can also use it, for instance, in an audio amplifier. Anyway, you can read how much voltage the audio amplifier takes and how much current. So I have to push the set switch to make it work. We read 22.7 volt at 1.3 ampere. I have to say the ampere is only an indicator. It's not very precise in this circuit, and I also could not find, say, a potmeter to tune it very fine. For hobby purposes that is absolutely no problem. You can use your own amps meter in the circuit, etc. So here is the load at the moment. Switch off the lights and you can see that it works. Put up the voltage and the current. 27 volt, 1.4 ampere. And now I switch on that switch. That switches out the shunt in the measuring unit here, this shunt here. And now we read 1.07 ampere. That's not okay. There is kind of current flowing somewhere. I don't do a deep analysis on where that current flows. It's not important for me. The output voltage is of course the same. When I switch it back, now it's no longer disabled, the ampere reading, so the output voltage stays the same. But that means that I can use this power supply for audio amplifiers. And that is the aim of this power supply, because I wanted to make audio amplifiers on voltages higher than 35 volts, and that's why I made this whole circus. Anyway, finally the schematic. Thanks for watching. Hope it was not too sloppy.